Okay.
So I went through quite some of the places where there was an, I'll let it load 1 second. So I looked at the places where the increase was greater than 200 and greater than 400%, just as like my base heuristic of what's some degree of significant change. Um,
Okay.
and I think most places I looked at,
What
what
is
was
these
happening?
wacky columns on the left? Start, call, carp. What's all that?
Oh, this is just like span gets split into multiple of them because it contains commas. So it's,
Got it. Got it. Got it.
yeah, let me see. So basically, yeah, what I was seeing was a lot of the places, the fields are being individually captured, and you have basically some immutable reference to the thing. Um, and you end up capturing a lot more than you can probably get by with. Let me
Yeah. So if you just had one reference to the root, you would, instead of making references to all the things. Right.
exactly.
Yeah. And that seems like a pretty easy optimization.
So there's the concern around if you're in a move closure, you can end up actually causing like you can this optimization can cause a regression because let's say you have some a root variable x which is a reference, doesn't matter what, you capture x dot y, and now since this is a move closure we will actually copy x dot y, and if y is let's say a 1 byte like a u8, it's cheaper to copy the u8 than to copy the reference because the reference will be 8 bytes on like your 64-bit machine.
There's a different problem that's even more important. If you, except I don't think it applies. I thought for move closures, we always stop at a pointer dereference anyway.
Not if it's a copy type. I think if it's a copy type, then it's safe to copy the data.
I don't think that's a good assumption. Like, go back to the example you had earlier.
This one,
Yeah. If you change string to like
I can just do
you,
this,
no, sure, okay.
right?
Yeah, okay. I would prefer that we capture all of it, but with the println example, but yeah.
Okay.
Well, let's see what does it do, because that has a bug, so this tells us more information. Yeah, this captures
So
x by value, right? That's what I expect.
that is also because it is, uh, hmm,
But this is a box also, not a reference, but I don't think it makes a
uh,
difference.
we can just do this quickly. That's not a concern. So, oh, it does do it. Interesting. Okay,
But
so it
this is
does.
the println case.
Mm-hmm.
This is a little different. If you do let x equals x dot 0 there, what does it do?
Oh, right. Well, it is also doing an immutable borrow. Interesting. Why did I think it would do copy?
A copy reads as an immutable borrow.
Mm-hmm.
So, I mean, I think that's okay. I'm debating about this right now. So, okay, there's two things going on. One is when you have a move closure,
Mm-hmm.
we had the sort of rule that we will only copy bytes that were on the stack frame.
Mm-hmm.
And so
Yes.
that means we have to copy the reference, right?
Yes.
Like we don't know that what's on the other side of that reference is in our stack frame. So we really don't have a choice if we want to keep that rule.
I think we made a decision that if or this was a copy type, then we can just copy because we don't really need to move it out.
But I don't think that's a good decision.
Okay.
Maybe we could make that decision, but one reason I don't think that's a good decision is that just because it's copy doesn't make it cheap to copy. It could be like
Yes.
a U8 1024.
Mm-hmm.
And
Mm-hmm.
now, and I remember us going on back and forth about this, right? Like if that were boxed or with the code as is, you're copying a pointer to a huge array. I don't think you necessarily want it to copy a huge array.
Exactly.
So I think it's better to say it's that way. It's always a subset of what we copied before. It never copies more data than it used to in a move closure.
Right, because it's through a reference, right? Because it's through a reference. That makes sense. Yeah.
Now, so that's one half of this. That's probably the whole story. The only thing I was thinking is there is one other catch though. In the case of a non-move closure that borrows two fields from a struct that is referenced by reference, you would get borrowed. It's not actually safe to borrow the whole struct all the time. Let's go. Can you open like a place I can type?
Yes, let's just do a HackMD.
And maybe I'll go out of this screen share, I guess, or I won't make it full screen anyway. Send me the URL somewhere. Yeah, we gotta start writing out the examples. There's a lot of them.
Let me. Where is Zoom chat? All right. How do I send things? I'll just send it on Zulip. Okay, perfect. I will paste my link there. Okay. Yeah, you should have access to edit, I suppose. All right. Should be good now. I changed the edit. I sent it on Zulip.
Okay, sorry. Let me find that. You sent it in the channel, I guess. Yeah, I see. Okay. Okie dokie. So, right. So first thing is rule number 1. For move closures, only copy data that was on the stack frame of closure creator. This means never pass through a dereference. Why? One reason why is let Xbox U8 1024, or like even if the full path leads to a copy type. And then whatever. Hold on. I guess x.len or something is a good example.
Yeah.
Okay. So that's rule number 1. But the other thing is, I think we can do this. It's just a little trickier than it sounds. So let's go for the first example. If I understood you, you have something like struct my struct. We have A, B, C or something. Let's not even make them so specific. And then we have and your point is might as well just capture M and not the two fields individually. And I think that's true for this case because, and I'll show you what I mean by this case. But yeah, because you're not gonna m.c, it doesn't like capturing m.c doesn't make any difference. However, a case where it might matter would be something like this. So here, if we capture M, our closure does not outlive tick static. Actually, hold on. Let me give these names because actually that's not a good example. So the problem is, this is true. This is true. Well, this isn't actually true. It does. There's got to be a way to make this into a problem, though. Well, it's not true because of implied bounds. Sorry. Let me think. Still, something feels fishy here. I might just let me think. Okay. Here's a different case. It depends. I guess there might be something like. Okay, so here we really do want to capture star m dot a because that outlives tick static, right? But it might be that that only applies in the event that one of the paths we've captured is passing through a second reference because of these implied bounds.
Wait, doesn't tick static outlive all other lifetimes?
Yes. The problem here is if we capture M, then the closure no longer outlives tick static, right? It's
right.
It is constrained to tick A or tick.
Yeah. Oh, I see what you mean. Yes. Right.
Go to tick A. So I'm trying to think if I can come up with an example that doesn't involve passing through a second reference where you get a similar phenomena. Like the first one you can imagine why my thought was, oh, well, we're only borrowing data that's owned by tick A, so to speak. Yeah. And there's this other field that has like data with tick B, so maybe that's a problem to now have access to that as well, except that I think I'm wrong because the basic well-formedness rules of Rust kind of require that, if some of the things are accessing fields of the struct and others are accessing like references that are found in fields of the struct, those references have to outlive the fields of the struct itself. So it's actually not a problem. It's only if you, yeah. So I think it's like I think a safe rule would be if you have a set of paths P with some common prefix that's like, hold on, if you have a set S of paths with some common prefix P where P equals star LV. No, this isn't making sense. But I'm trying, let me rephrase this another way. If you have, here's a really simple case, this is not as general as it could be, a variable X of type $t, and you capture a set of paths, sort of star X dot field 1 through n, you could instead just capture X. That seems true. Borrow. This is borrow.
Yes, that's the basic one.
Yeah,
Yes, that's the
but,
one.
but this doesn't match the star m dot a example because that's a more complex path, if that makes sense.
So essentially, we're removing that deref thing from there.
Yeah,
No.
because I'm basically saying as long as you have some reference and you access fields owned by that reference or owned by the thing that reference refers to, the referent of that reference, you can take all those fields away and just capture the reference. But if you go through a reference and use that to reach a second reference, that's not true anymore. You have to, so it's only like, you can kind of say, in other
Only one
words,
deref.
yeah, in other words, this is the way to go. If you have the rightmost dereference in the path, you can strip off all the fields that come after it.
Yes.
That's basically it, at no cost. There's a slight cost. I think like in the corner case of a field of type U8, your closure might get bigger. But most of the time, you can strip off those fields, and that works in all our examples. But the idea would be, so rule, given a place P, find the last dereference. I'll call it the rightmost. You know what I mean by that, right? Outermost or something. D. If it is a deref of a shared ref, you can truncate P. You can truncate P, or if it's a deref of a shared ref, and all that follows are field accesses, you can truncate P to remove the field access. That may be, I think that might be like, that's the only thing they could follow, because it would either be a deref, in which case it's not the rightmost, or it would be fields, but maybe there's a third case I'm not considering.
Not unless we start doing precise indices and subslices. Until then, we're good.
So in that case, for like example one, ooh, my Greek keyboard turned on there. Example one, caps lock key turns on my Greek keyboard, but I hit it by accident sometimes. Example one, that's this one. This is example two. Example one, you access, right, star m dot a. This is really a borrow. Actually, this rule is probably safe even for U8s, as long as they're borrowed, because you're going to make a pointer anyway, right? It's only by move when it doesn't work. So you borrow star m dot a, and then you basically truncate to borrowing, or to, borrowing m, I guess. You don't want to borrow m, you want to capture m by value.
No, I think we want to borrow m. It's like the benefit of borrowing m is we also get around the fat pointer issue we were talking about last time.
Well, okay.
Because like, if we also think about what would have happened if, assuming m was just a root variable, and what we would have done without this precise analysis, we would have borrowed m. So we would have always borrowed a reference to the reference.
Yeah, I'm just thinking that you do actually lose something there, because if you, in this example,
Which one?
Example one, if you borrow m, you are now not able to return that closure.
Oh, I see. Yes, you are right.
And we do want to return that closure. So we can't actually borrow m, even though what we could borrow star m.
Yes, but
then you're saying, well, no, but there's a potential fat pointer issue where star m dot a might not have been a fat pointer, but star m might be. It's going to be pretty unusual, but not impossible. Like you could have a struct that has a yeah, it's rare. It's pretty rare
Okay.
to have a struct that like you have to use unsafe code and a bunch. You have to work pretty hard to make a struct whose final field is unsafe, or is it's possible to do, but it takes real effort to do.
Okay.
I'm gonna say capture M by value.
Okay. Also, how early do we want to do this
Yeah.
precision? Like, do we want to only do this analysis on root variables, or do we want to do this analysis properly, looking at all precise paths and then trying to come up with, like basically as soon as we
You
can
mean
do
like when we're constructing the initial set of accessed
exactly.
paths? I
Yeah.
think we could do it then.
Yeah. Okay.
It'll just make less work later on. Like we're not losing any precision
Yes.
that way. Okay, so then yeah, and then star M. So basically in example one, both of these would wind up getting truncated to the same path. So we would wind up with like, as if we only accessed one thing, M by value, right?
Mm-hmm. Yeah.
But in example two, we access, it's really star M dot A. Yeah, that's kind of what we accessed. And here the rightmost
DREF
is the second one, so nothing changes basically. You know.
Yeah, it's after the
If this had some further fields, like let's do that just to make it more interesting.
Mm-hmm.
So now it would be like this dot field of A, and then we could say truncate to
star. Yeah. And we capture this by reference.
By value, I
Oh,
think.
well, okay, sorry. This, yeah, if A is a reference, then capture by value. Yeah.
Yeah, an alternative way to see it is capture the deref by reference, which is the same thing. I think.
Yeah.
So, but that's fine. We're capturing this tick static now, which is what we wanted, not the
Yeah.
And this is guaranteed to be a copy.
Yes.
Because that is a shared reference, and so is this. So that means it can't be producing any borrow check errors by the fact that we're now like moving it in. So I think this is a safe optimization.
I will add this to here.
Now, I have a question about do we have a plan to who wrote me here? Okay. Tie this to the addition?
Yes, I was going to bring that up as well. I don't have any problem to tie this with the addition. I want to discuss what all do we tie to the addition right now. Is it just that, sorry, is it just that the feature is enabled by default, or do we also want the lint to be start triggering on edition 2018 as a future?
No, we want it to. So when you're in edition 2021, it should turn the feature on by default. And the lint, I think, should never trigger by default, but it should be part of the group.
Edition 21 lints.
Yeah, and I'm not sure how. I think you make that. I think you do that by making it allow by default, but adding the like future incompatibility metadata that ties it to the addition.
You can. So there's a lint group thing that is in Rust lints. So you can just like list it as part of another lint.
I know, but I think that lint group for the additions is special in some way, like synthetically generated. And so I think you do it by setting the metadata on the lint itself.
Nice. So I don't, okay, so it feels incorrect to say it's a feature incompatible thing because
I don't like that field. I think that field, we should refactor it because in my view, there's like future incompatible in my view means we are going to change the meaning of this code. This is a bug. And addition is not a bug. Addition is like a different thing. It's addition incompatible. It's a migration. So I think that should be refactored. However, that's an orthogonal problem. As far as I know, that's used, that metadata is used for all addition stuff right now.
So, and we says the future incompatible and lint metadata. Okay, yeah, so this is all I have. I think Dhruv didn't get time to work on the, what is it called? Where's the migration where we want to figure out, oh, yeah, there actually, this is also a thing that we need to do, but figure out the the significant and insignificant destructors. Sorry, I was forgetting words. And then we also have this issue that we had previously talked about, where we have a structure that contains two drop types. Now, the drop has been reordered because now we will drop p.y before we drop p.x, which previously, if p was completely captured, would drop p.x before it would drop p.y. So we basically need to sort of sort through our list of captured precise paths to maintain drop.
Yes, but we just need to sort that list, right? By,
I think so.
in fact, it's probably just sort by field index.
Yes, I think so.
It's actually pretty easy. Okay.
Yeah, so it shouldn't be that bad. Yeah, I think that's mostly what we have remaining. I'll file the bug for the boxing right now, and box, okay, box capture. Yeah, so I think that is all I have for questions. So we want, for the data that's generated out of the actually closure size, actually you realize I have a couple questions around that now that I forgot. One, when it will probably be, so I'm assuming we're expecting people to use this with cargo, and they set the Rust flag, like pass cargo, the Z profile closure flag. And in that case, from what I understand, it will only generate it for the current project and not for any of the dependencies and stuff, which means we will lose, we can probably lose some important metrics there, though we can also just run that profile ourselves on public, like common Rust dependencies and like repository. So get the data that way.
Sorry, I'm a little confused. Oh, it'll only show you the crate that the user is testing. Yeah, that's okay. I think that's okay.
Okay.
I'm feeling pretty good about the data so far. So
yes.
Yeah, I think we should try it on a few. We can look at the top 3 downloaded crates or something, or top 10 or whatever we want ourselves. That'll cover the vast majority.
All right. Okay. Yeah, that I think works.
Besides, I think a lot of crates like Saturday and so forth wind up generating code in the user's crate, right? So
okay. All right. Yeah. Okay. And then we just generate a CSV out which contains. Okay. Also, I wanted to discuss was, do we want to give the user just an option just called Z, like profile, and they can just set equals no collect so that we don't collect span information, or do we just want to like tell them to not share, like I feel like them having to go remove the span is going to be painful just because there's so much data that will be there. They would have to either open this up in a actual edit, like a Google Sheets or some kind of editor to delete it, or
I don't think we should. Why would they? I don't want them to delete it. Like, we might want to look at that data. I think we should tell them that it's just be advised it's going to contain span information and may reveal the name of your directory or whatever.
Okay.
It's not like a
Okay.
huge security breach.
Okay. Okay. Yeah. So those were the 3 questions I had around that.
They could always pipe it through Perl Pi or whatever if they're really concerned.
Like, yeah, they would have to do work too, kind of.
Yeah, but it's not so hard to do. Anybody who cares about revealing the name of their username and still probably cares enough to run Perl and do a regular expression. So
Fair enough. Fair enough. Okay, so.
But we should definitely disclose it. It's a good call out.
Yeah. Okay. Yeah, that's all I have. Do you have any questions for me?
My only question is, what's the status of the various folks in the group? Is it just you now, or are there other people still working on stuff? And do you have a timeline on these things?
So
how busy are you all?
So Dhruv started work, so he's probably busy, but I think he said he will get started on the Incident and Destructor soon. I think right now it's just me, and I think Roxanne was on vacation, but should be back soon. So
Okay.
I'll check in with her.
Okay. I just want to make sure that if it happens that your available bandwidth is dropping very low, since the timeline is starting to matter, do let me know and I'll try to figure out how to fill that gap.
Okay.
That's all.
I think there isn't too much left.
No, we're very close.
Yeah, so I'm not too concerned. But yeah, I'll let you know if I figure out we don't have enough bandwidth to finish this stuff up.
Is there any other, I think the only blocker for people testing the edition is the tie to the current edition issue.
Yes, that's
well,
like
and this bug you just discovered. But
yes.
Okay.
We also had this one issue that we wanted to do as a polish complete, which was, oops. So 1 second. Yes. So basically, simple example. This code, which basically when you coerce a closure to a function pointer, it currently looks at upwards and not the captures list. So it is possible.
Yeah, I remember this. We can tweak that at some point. I'm not too worried about it.
Okay, yeah, because from what I remember, this is going to be some degree of significant rework because we would have to get the obligations and stuff set up.
Yeah, it's a little bit of work. I don't think it's worth worrying about very much.
Okay.
It seems like quite the corner case.
Okay.
All right.
All right, that's all I have. Thank you.
Cool. Talk to you later.
See ya.